If the latest images from the James Webb Space Telescope had already expanded the limits of our imagination, what you are about to discover completely redefines what we think we know about the cosmos. A new space observatory has begun, almost in silence, transmitting images so vast, so precise, and so deep that even the researchers themselves admit they were caught off guard. The Euclid Space Telescope has now revealed its first light images, and they do far more than showcase breathtaking galaxies. They reveal structures we barely know how to interpret, patterns carved by invisible forces, and a universe that appears far more intricate and unsettling than we once assumed. Tonight, I will guide you through what Euclid has recorded, explain why astronomers describe these images as transformative, and show why some of them become genuinely disturbing once you understand what is truly before your eyes. Stay until the end, because this represents only the beginning of what Euclid has yet to uncover. But before we begin, don't forget to like and subscribe to our channel. Euclid is not a conventional space telescope. It was never designed simply to highlight a specific nebula or zoom in on a particularly spectacular galaxy. Its true mission is far more ambitious and, in certain respects, more unsettling. Launched by the European Space Agency in July 2023 and positioned 930,000 miles from Earth at the Lagrange Point 2, Euclid was designed to map the universe in a dimension we have never dared to explore. Its extremely wide field of view allows it to capture vast regions of the sky in a single exposure while preserving extraordinary definition. This means Euclid can observe individual galaxies in sharp detail while revealing how millions of them intertwine within gigantic cosmic structures. What is truly disturbing is that Euclid is not merely recording visible light. It is tracking the influence of dark matter itself through subtle distortions in the shapes of galaxies caused by gravitational lensing. Put simply, Euclid is exposing the skeleton of the universe, an architecture shaped by something invisible and not yet fully understood. When Euclid transmitted its first large mosaic of the southern sky, the scientific community was stunned by the magnitude of what appeared before them. In a short observation period, the telescope assembled 260 images covering a region of sky 500 times larger than the full moon. When combined, these images revealed millions of stars and galaxies, representing only about 1% of the complete map Euclid intends to build. That fact alone is unsettling. What you are looking at is not the final portrait, but merely a fragment of something inconceivably vast. Scientists can zoom in from the largest cosmic webs down to individual galaxies without losing clarity, demonstrating how matter organizes itself across colossal distances. This mosaic is not just a photograph, it is a preview of the largest and most detailed three-dimensional map of the universe ever attempted by humanity. And it immediately raises uncomfortable questions about how little of the cosmos we have truly explored. One of the most disturbing revelations from Euclid's first images comes from the Perseus cluster, located about 240 million light-years away. That single image shows more than 1,000 known galaxies, along with over 100,000 distant background galaxies. But the real shock came when scientists looked closer. Euclid discovered more than 630 previously unknown dwarf galaxies hidden within the cluster, objects so faint that they had escaped detection until now. This matters because dwarf galaxies are extremely sensitive to the gravitational influence of dark matter. Their shapes, positions, and distortions act as tracers, revealing where dark matter is concentrated. The fact that so many of these galaxies remained invisible until Euclid's arrival suggests that the influence of dark matter may be far more intricate than previously believed. The universe does not merely contain dark matter, it appears to be structured around it. Euclid's images are not only reshaping our understanding of large-scale structures, but also exposing a new level of complexity on smaller scales. In galaxies such as NGC 6822, Euclid revealed low metallicity stars that resemble conditions in the primordial universe, offering a glimpse into how galaxies evolved billions of years ago. In globular clusters like NGC 6397, Euclid was able to resolve faint stars in the outer regions that were previously overshadowed by brighter ones, unlocking new clues about the history of the Milky Way. And in regions such as the Horsehead Nebula, Euclid's sensitivity revealed evidence of rogue planets and Jupiter-mass objects wandering without stars, suggesting that solitary planets may be far more common than once imagined. These images paint a portrait of a universe that is not calm or orderly, but dynamic, dense, and constantly reshaped by visible and invisible forces. As scientists began assembling more data from Euclid, an unsettling pattern became impossible to ignore. Galaxies are not scattered randomly. They arrange themselves along vast filaments, immense cosmic threads stretching across hundreds of millions of light years, intersecting at dense nodes where galaxy clusters form. Euclid's images make this structure painfully clear. It looks less like a peaceful universe and more like a gigantic neural network, with matter flowing along invisible pathways shaped almost entirely by dark matter. These filaments are no longer merely theoretical. It is possible to see their influence directly in the way galaxies curve, stretch, and align. The most frightening part is not their existence, but their scale. This cosmic web dominates the universe, and everything we see, every galaxy, every cluster, every void, is trapped within it, guided by forces we still cannot touch or directly detect. One of Euclid's most unsettling capabilities is its precision in measuring gravitational lensing. By detecting tiny distortions in the shapes of distant galaxies, Euclid effectively reveals where dark matter is hidden. These distortions are subtle, almost imperceptible without Euclid's resolution, but when mapped across millions of galaxies, a clear picture emerges. Massive regions of dark matter bend space itself, warping the light of objects behind them. What makes this disturbing is that these gigantic structures are completely invisible. They emit no light. They reflect none. And yet they outweigh everything we can see. Euclid is showing us a universe in which the dominant form of matter is something we cannot directly interact with, something that silently controls the motion and fate of entire galaxies. Euclid's reach into deep time adds another layer of unease. Some of the galaxies captured in its first images are more than 10 billion light-years away, meaning their light began its journey when the universe was still young. By observing these ancient galaxies alongside much closer ones within the same frame, Euclid allows scientists to trace how cosmic structure evolved across most of the universe's history. What they are seeing suggests that large-scale structure formed earlier and more efficiently than expected. Galaxies clustered more quickly. Dark matter organized itself sooner than predicted. The universe may have matured far faster than our models indicated. This forces a reassessment of how cosmic evolution truly works and whether our current understanding of gravity itself is complete. Perhaps the most unsettling fact of all is this. Everything you have just heard comes from approximately 1% of Euclid's planned survey. 99% of its map is still to come. Over the next 5.5 years, Euclid will continue scanning the sky, filling in gaps, refining structures, and revealing patterns we do not yet even know to look for. If this is what the universe looks like at 1% resolution, the complete picture may be overwhelming. Euclid is not merely collecting images. It is building a dataset so vast and detailed that it may force fundamental changes in cosmology, from the nature of dark matter and dark energy to the laws governing the expansion of the universe itself. One of the most unsettling revelations emerging from Euclid's data does not concern where galaxies are, but where they are not. Vast regions of space appear almost empty, enormous cosmic voids stretching across hundreds of millions of light-years. But Euclid shows that these voids are not truly empty. They are shaped, bounded, and defined by the same invisible forces that build galaxy clusters. The distribution of galaxies around these voids suggests that dark energy may be pushing matter away, accelerating the expansion of space itself. In Euclid's images, these voids look less like gaps and more like pressure zones, regions where the universe is being stretched. The unsettling implication is that the large-scale structure of the cosmos is not merely expanding passively, it is being actively reorganized. Euclid was designed not only to map dark matter, but to investigate dark energy, the mysterious force believed to drive the accelerated expansion of the universe. By measuring the positions and redshifts of billions of galaxies, Euclid can track how the rate of expansion has changed over time. Initial analyses of its first data indicate subtle deviations from expected models. These deviations are small, yet persistent. They suggest that dark energy may not be constant, as once assumed, but evolving. If confirmed, this would fundamentally alter our understanding of cosmic history. The force shaping the destiny of the universe may be more dynamic, more complex, and less predictable than we ever imagined. As Euclid's datasets grow, scientists face a new kind of challenge. The scale of information is overwhelming. We are no longer talking about thousands or millions of objects, but billions of galaxies mapped in 3 dimensions. Human intuition struggles to cope with that scale. The patterns that define the universe are too vast to be understood without advanced algorithms and artificial intelligence. In a sense, Euclid is forcing us to rely on machines to understand what machines themselves have observed. This creates a strange feedback loop, in which our knowledge of the universe increasingly depends on systems that interpret data beyond direct human comprehension. The frightening aspect is not the data itself, but how much of reality may exist beyond what our minds can intuitively grasp. Perhaps the most disturbing implication of Euclid's first images is what they suggest about the foundations of physics: dark matter, dark energy, gravitational lensing, accelerated expansion. Together, these phenomena dominate the universe, yet they are explained by theories filled with gaps and provisional assumptions. Euclid's clarity exposes how much of our cosmic model rests on unknowns. We can map the effects with extraordinary precision, but we still do not know the true nature of the forces behind them. Euclid is not merely revealing the universe, it is revealing the limits of our understanding, presenting a cosmos in which most of what truly matters is invisible, unexplained, and known only through its influence on everything else. At first glance, Euclid's images are breathtaking. Galaxies glow, nebulae twist, and star clusters shimmer with almost artistic balance. But the longer scientists study these images, the more unsettling they become. In this case, beauty is not comfort. It is precision. Every sharp contour, every perfectly defined filament, every delicate distortion is evidence of forces working relentlessly across unimaginable distances. These images are beautiful because the universe obeys its rules with relentless consistency. Gravity never rests. Dark matter never loosens its grip. Expansion never slows. What appears visually serene is, in reality, the signature of a cosmos that is constantly pulling, bending, and stretching everything within it. Euclid's data strongly reinforces a disturbing idea. Galaxies are not the architects of cosmic structure. They are the decoration. The true builders are invisible. Dark matter halos form first, collapsing under gravity long before stars ignite. Only afterward do galaxies emerge within those halos, illuminating regions already shaped by something we cannot see. Euclid's ability to map galaxy shapes alongside gravitational lensing makes this hierarchy impossible to ignore. The visible universe rests upon a hidden framework that determines where galaxies can exist and how they evolve. The frightening implication is that everything we are able to observe is secondary. almost superficial, compared to the invisible mass that controls the cosmos. One of the most remarkable aspects of Euclid's observations is the way it compresses cosmic time into a single image. In one photograph, you can see nearby galaxies as they are today, distant galaxies as they were billions of years ago, and faint structures formed shortly after the universe began. Past and present coexist within the same frame. This means Euclid is not merely recording space, it is recording history. Scientists can trace how galaxy shapes change, how clusters evolve, and how the influence of dark matter intensifies over time simply by comparing objects at different distances. The unsettling realization is that what we call now is only a thin slice of a much larger cosmic process that began long before Earth existed and will continue long after it is gone. As Euclid advances through its 6-year mission, researchers are beginning to suspect that its most important discoveries may not be the ones it was originally designed to make. The telescope was built to study dark matter and dark energy, yet its unprecedented resolution and scale are already revealing anomalies, unexpected alignments, and subtle patterns that do not perfectly fit current models. History shows that when a new instrument opens such a wide window, surprises are inevitable. Euclid may end up forcing revisions not only in cosmology, but in fundamental physics itself. The truly unsettling possibility is that the universe Euclid is revealing may not be fully explainable with the tools we possess today. One of Euclid's most disconcerting strengths is its ability to show the universe on two completely different scales at the same time. In a single observation, the telescope captures vast cosmic structures stretching across millions of light years, while also resolving fine details within individual galaxies and star clusters. This dual vision reveals something profoundly uncomfortable. The same invisible forces that shape the largest filaments of the cosmic web also influence star formation in small, irregular galaxies. Euclid shows that the universe is not organized in a simple hierarchy from large to small. Everything is connected. Large-scale gravity determines local behavior, meaning that events occurring at incomprehensible distances can silently shape what happens within a single galaxy. The universe is not modular. It is systemic. Many of the regions photographed by Euclid were already familiar to astronomers: Perseus, the Horsehead Nebula, nearby globular clusters. And yet Euclid revealed features in these familiar locations that no one had ever seen before: new dwarf galaxies, hidden star clusters, faint stellar populations that had been obscured in previous surveys. This raises an unsettling question. If we were so mistaken, or at least so incomplete, about regions we believed we knew well, how much are we failing to perceive in places we barely know at all? Euclid quietly demonstrates that familiarity can breed false confidence. The universe we thought we recognized still contains layers we had never uncovered, simply because we lacked the proper perspective. Euclid's ability to observe galaxies up to 10 billion light-years away turns the telescope into a true time machine. The farther it looks, the younger the universe becomes. By combining visible light images with infrared measurements, Euclid enables scientists to position galaxies precisely within three-dimensional space and time. This makes it possible to reconstruct how cosmic structure grew from an almost uniform primordial universe into the complex web we see today. The unsettling realization is how quickly that structure appears to have formed. Dark matter clustered early, galaxies followed soon after. The universe organized itself with an efficiency that challenges slow-growth models. Euclid suggests that cosmic evolution may have been more intense and more decisive than we assumed. As Euclid's first data continue to be analyzed, a pattern begins to emerge, something every astronomer recognizes but never celebrates. The number of questions is growing faster than the number of answers. Every newly mapped structure introduces anomalies. Every new gravitational lensing signal raises doubts about the nature of gravity. Every refined measurement of expansion pushes dark energy models closer to uncertainty. Euclid is not merely filling gaps in our knowledge. It is exposing how provisional that knowledge truly is. The frightening part is not that we do not yet have answers. It is that the universe Euclid is revealing may require questions we do not yet know how to formulate. When you step back and look at everything Euclid has revealed so far, one thing becomes impossible to deny. These images are not frightening because they show monsters, explosions, or cosmic disasters. They are frightening because they show order. A precise, structured, deeply interconnected universe governed by forces we cannot see, cannot touch, and still cannot fully explain. Dark matter is not a supporting character. It is the chief architect. Dark energy is not a background theory. It is actively pulling the universe apart. And gravity, as we understand it, may not tell the entire story. Euclid forces us to confront an uncomfortable truth. Most of the universe is invisible, and most of what truly matters operates beyond our direct perception. Galaxies follow paths they did not choose. Structures form where invisible mass allows them to exist. Even empty space is shaped, stretched, and sculpted by forces older than the stars themselves. What seems distant and abstract becomes intimate, because this same cosmic machinery shaped our galaxy, our solar system, and ultimately us. Think about that. We are not standing on solid ground in a calm universe. We are traveling within a vast, dynamic structure built upon physics not yet fully understood, moving through space according to rules we have only begun to glimpse. Euclid's images are beautiful, yes, but they are also honest. They show us a universe that does not revolve around what we can see, what we can easily measure, or what brings us comfort. And this is only the beginning. Euclid has completed only a fraction of its mission. 99% of its map remains to be revealed. If these first images are already challenging our understanding of dark matter, dark energy, gravity, and cosmic evolution, imagine what the full panorama will force us to reconsider. If you want to follow these discoveries, if you want to understand what these images truly mean rather than simply admire them, share your thoughts in the comments, because this is one of those moments when science quietly rewrites the rules. And remember, the universe Euclid is revealing is not new. It has always been there.